In this video, we're going to take a look at multiplying matrices together. We're going to break this objective up into a few videos for the purposes of time. So multiplying matrices, in the last video we looked at multiplying a matrix by a scalar or a real number. In this video, we're going to take a look at multiplying matrices together. Now, unfortunately, it does not work in a way that you might think it does. And that means because when we multiply matrices, we do not multiply corresponding elements like we add and subtract corresponding elements for addition and subtraction. So instead, what happens is we multiply the corresponding elements of a row by the corresponding elements of a column and store the sum of that result in the intersection of that row and column, or in the row number and column number of our answer. Now, even writing this out, it doesn't really do it any justice because it's not very easy to understand. It's matrix multiplication is one of those things where you just have to see it and see some instances of it and get familiar with it to the point where you can do it. Matrix multiplication is used a lot in graphic, like computer graphics, with especially rotating large sets of points. So for like video games and things like that, where you need to configure a bunch of coordinates very fast, you can use matrix multiplication, among many other applications. So that being said, we can only multiply matrices if the number of columns in the first matrix equals the number of rows in the second. Our final result is going to be a matrix where the dimensions are equal to the number of rows in the first matrix by the number of columns in the second. So let's see this in action so it makes a little bit more sense. So here we have two matrices. We have matrix D has 4, -1, -7 in the first row, and then 2, 0, 6 in the second. And then matrix E has 3 rows here with a 1 and a 9 in the first row, a 3 and a -2 in the second row, and a 4 and a 0 in the third row. Well, just like with addition and subtraction, first thing we want to do is want to check the dimensions of each matrix. We don't want them to necessarily be equal, though, but we do want to know what the dimensions are. So the dimensions of D are 2 rows by 3 columns, and the dimensions of E are 3 rows by 2 columns. So since the number of columns in D, which is 3, equals the number of rows in E, which is also 3, we can actually multiply the matrices together. And the product, our answer, is going to be a matrix with 2 rows and 2 columns. So these outer dimensions, the number of rows in D and the number of columns in E, will tell you what the size of your matrix is going to be for your answer. All right, so we're going to do this very systematically to keep it organized. We're going to start with the first row in matrix D, and then we're going to multiply it by the first column in E, figure out what that answer is, and then multiply it by the second column in E. Then we're going to move on to the next row in D, the bottom row, and then repeat the process. Multiply the bottom row by the first column in E, and multiply the bottom row by the second column in E. So once you get the hang of it, it's pretty easy going from there. All right, so I'm just going to give myself enough space to write. So first, we have 4, -1, -7. We're going to multiply that by 1, 3, and 4. So 4 times 1, -1 times 3, and -7 times 4. When we figure out those products and add our results, again, this is the first row and the first column. We put our answer in the first row, first column, and that answer comes out to equal -27. Now we're going to move on to the second column of E. So we have the first row, second column. That answer is going to go in the first row, second column. So first row, second column. So now we have 4 times 9, -1 times -2, and -7 times 0. When we simplify this expression, we get 38. So we filled out the first row of our answer. So now we can move on to the second row in matrix D and repeat the process. So we have 2, 0, and 6. We're going to multiply that by 1, 3, and 4, and we're going to put our answer in the second row, first column, and that's the second row, first column. It's the bottom left of our answer. So 2 times 1 plus 0 times 3 plus 6 times 4. When we calculate all this out, we get 26. And then finally, the second row, second column, and the answer to that's going to go in the second row, second column. So we're going to have 2 times 9 plus 0 times negative 2 plus 6 times 0, and we end up with 18. So our final answer is a 2 by 2 matrix where the first row has negative 27 and 38, and then the second row is 26 and 18. And always, always, always remember to check that the number of columns in the first matrix equals the number of rows in the second. If it's not the case, then we cannot multiply the matrices together. If E was, let's say, 2 by 2, we'd have 3 numbers in this one and only 2 numbers in the column to multiply and add. So we leave out this last one here if this 4-0 row was not in matrix E. So again, always remember to check that condition that the number of columns in the first matrix equals the number of rows in the second. All right, so that about does it for this video. Thanks for watching. I'll see you next time.